Algebra 2 state sample question number 23, likely number 24 and 25 also. We'll see how many we could get in on one video here. But here's number 23, right? 5 plus 2yi times 4 minus 3i minus 5 minus 2yi times 4 minus 3i in a plus bi form where y is a real number. So we basically want to simplify this down as much as we can. There's two ways to really do this question. One is to let's multiply this out, and then worry about the subtraction. And that might be what most of you would do. So let's see. When we multiply out this piece over here, it's going to be a double distribution. 5 times 4 is 20. 5 times negative 3i is negative 15i. 2yi times 4 is 8yi, and 2yi times negative 3i is negative 6yi squared. Squared didn't really fit in there. Negative 6yi squared. Now, the one rule for I you really want to remember is that I squared rule, that I squared is negative 1. So this whole term is going to change to be plus 6y. So let me rewrite that. So again, I want to keep this in parentheses because it's this whole thing minus this whole thing. And if I forget about those parentheses, then that'll probably mess up the subtraction in a little bit. So let me keep it in parentheses, keep that there. 20 minus 15i, I have no like terms, at least not right now, plus 8yi, and then this will become plus 6y, because the I squared here is negative 1 times negative 6y is plus 6y. So there are no like terms in here to combine. Minus now the grouping over here. So when I multiply these, so again, I'm ignoring this minus sign. I'm going to save that for later. 5 times 4 again is 20. I'm going to see a lot of repetition, I think. 5 times negative 3i, negative 15i. In here, we'll get a negative 8yi and a positive 6yi squared. And then, of course, this with the I squared is going to simplify down to be 20 minus 15i minus 8yi and minus 6y. Then the fact that I'm subtracting all of this, the best way to do that is to kind of distribute the subtraction into it. I got to minus each of these, kind of negating all of them, and that basically changes all of their signs. There's other ways to think about this, but I like to think of it as just kind of changing all the signs to the right of all that stuff in there. I got a minus 20, and minus a negative is positive. Minus a negative, so they all become plus. And basically combine them with the like terms I have over here. 20 and negative 20 cancel out. Positive 15i and negative 15i cancel out. 8yi and 8yi do not cancel out. That'd be 16yi. And 6y do not cancel. That would be 12y. And then you may think that that's the final answer, but there's one small thing you need to do. You cannot combine them, but a plus bi form states that when you have two things, the I must go last. So any expression with I, such as 16yi, that's got to be on the end of the expression, not in the beginning. So I need to actually write my final answer as 12y plus 16yi, which seems silly, but that is what they want, and they are very specific about that, and the rubric would say minus 1 point for this answer, which is kind of dumb, but so that is that, and this was a positive 16, a positive 12, so I could just flip them around. Now I said there was another way to do this. The other way was recognizing they both have 4 minus 3i. You could factor out a 4 minus 3i, and then you're left with these two things subtracting, but then you still need to multiply, and this is really the only way. There is another way. Like I said, I could show that whole thing, but I don't think it's really necessary. You could try it and see if you get the same answer. You should if you do it right. Now this question is designed so you can't just type it into your calculator. The presence of the y is what does that. If it was just numbers and i's, then we could just type it in, and our calculator would do it for us. But they don't want you to do that. They want to design problems where you got to do the work yourself. So it's really just multiplying and subtracting numbers. It's really kind of an Algebra 1 concept. All we're adding to it is that we have the I squared that changes terms, to times negative 1, what they were. and then in the end, any term with an I has to go last. So that was really what's added to this, other than just some basic algebra stuff. All right, let's look at number 24. Use an appropriate procedure to show that x minus 4 is a factor. Oops, sorry. X minus 4 is a factor of the function f of x. So on. Explain your answer. So how can I show this is a factor? Well, I could try to factor this, but I'm guessing it's not factorable, at least by conventional methods. You know, I take what I take out here. I'm not going to get the same thing on this side, so can't do grouping. Of course, I could look on my calculator and see that this x equals 4 is a 0 or root, which means x minus 4 is a factor. But again, that's not going to help me for showing my work. And they're kind of telling you it's a factor. They want you to show that it is. So basically, the way we do that is we're looking for a remainder of 0. This is a remainder theorem question. If when you divide something and get a remainder of 0, that means it's a factor. Now, two options here. You could do long division or synthetic division. Synthetic division is much easier, much quicker, and that's what I would choose to do here. Now, the thing you have to remember about synthetic division is it uses the root, the 0, when we do the division. So the x minus 4, I have to think of it as x equals 4 when I do synthetic division. And then I take my coefficients, double check to make sure you don't have any holes. 3, 2, 1, none. So we're good there. But if there are, you'd have to put a 0 in a spot, like if I was missing an x to the first term, so on. All right, synthetic division. Bring down the first number times the 4 on outside gives me 8. Add these together to be 3. Times the outside to get 12. Add these together to get 1. Times the outside to get 4. Add these together to get 0. Check. This is my remainder. So it is 4 is a root, which means x minus 4 is a factor. So I would say because a remainder of 0, I mean, I'm doing a terrible job of wording this. Because a remainder of 0, comma, x equals 4 is a root or 0 or x-intercept. Therefore, x minus 4 is a factor. As I said, the other option here would be to do long division. And we have other videos kind of showing you how to do long division, but that would also work. And you would end up getting the same thing here. Like we could actually make this now into 2x squared, one exponent less than the original, plus 3x plus 1. So that would be the quotient with a remainder of 0 if I did long division. So try it yourself. Try doing long division of this divided by this and see if you could get that expression. You should. And it should work out well. Another option is plugging in 4 in here and you get 0. So there's a couple of different ways to do that. But it is a factor or it is a root when we have a remainder of 0. What trips people up is they do a negative 4 here with synthetic division, or they make a mistake in the long division process. But it's all about remainder of 0 proves something is a factor. And then explain means we need words. A couple of sentences explaining why what I did answers what this is here. All right, let's go for the last one, number 25. Solve algebraically for all values of x. Okay, this is a radical equation. And this is a square root right here, and I'm going to have to get rid of that. The way we undo square root is the inverse operation, of course, which is squaring. But I can't do that yet. You always got to isolate this. I want that to be the only thing on one side, so I got to move this x over first. So the first step is to isolate the radical. So x minus 5 equals 7 minus x. Now that it's alone, I may square both sides. Square both sides. And when squaring a square root, you're just left with the piece inside. Over here is a binomial squared we do all the time. Square the front, times each other double. Square the back. First piece is positive, last piece is always positive. The middle could be positive or negative. It is the sign of whatever we see here. The times each other was negative 7x, doubles to negative 14x. If you don't like that little mental shortcut, you could always think of it as 7 minus x times 7 minus x and do your double distribution. Combine like terms, you'll get this. Recognizing here, I'm going to have to factor this, so I'll set it equal to 0. X squared is positive over here. I'm going to rewrite it so that's in the front. Minusing x over to the right to be combined with the negative 14x is going to give me negative 15x. And adding 5 to the 49 would be plus 54. Factoring, so keeping it set equal to 0 would be x minus 6 and x minus 9. They're the numbers that multiply to positive 54, add to negative 15. You may have to guess and check a little bit in your calculator. I've showed you a shortcut before where you could always, if you're not sure, type in 54 divided by x, the number divided by x, and then take a look at the table. So I've hit second graph. It gives me all the numbers that multiply to 54, 1 and 54, 2 and 27, 3 and 18. But I'm looking for a pair that adds to negative 15. So I got to look, what do these add to? Negative 15, negative 15. Negative 3 and negative 18, well, if they were opposite signs, they could give me negative 15, but that's not quite it. But here's negative 6, negative 9. They add to negative 15. So take your time with that. Check it out. So we end up then solving each factor equal to 0. And solving, I get x equals 6 and x equals 9. But I need to check them. A lot of times, something rejects here. So I'll plug it in. When I plug in 6 minus 5 plus 6 equals 7, and 9 minus 5 plus 9 equals 7. Let's see. This is the square root of 1 is 1 plus 6 equals 7. That is going to come out true. 9 minus 5 is 4. The square root of 4 is 2 plus 9 does not equal 7. So this gets rejected. And you actually have to cross it out and write the word reject. The other thing is, at this point, if I look at it from this stage, if I were to plug in 9 here, I'd get 7 minus 9 is negative 2. And we cannot have a square root equal to a negative. That's a big reject issue right there. So the 9 rejects, the 6 is kept, and that's the answer to that. All right, so that's sample questions number 23, a little bit of powers of I stuff. 24, remainder theorem, must have a remainder of 0 to be a factor or a root, and 25, a radical equation. See ya.